Work on areas of composite figures, and this is going to bring together all of our area formulas. A composite figure is just a figure that's separated into regions that are just basic figures. So right here is an example of a composite figure. It's a rectangle, and within the rectangle are circles. So we're going to have to combine numerous area formulas to find the area of the composite figure. So basically, if you have a figure like this, you would figure out the entire area of the rectangle. And then you would take away the area of each circle. Sometimes you're going to have composite figures like this where you're not taking anything away, you're just finding the sum of all the figures. So in this example, example B, you would find the area of the rectangle and then you would add it to half of a circle. So to find the area of a composite figure, you're going to first find the area of each shaded figure and then add all the shaded figures together. So in this example, you find the area of each shaded figure and then add the two shaded figures together. If the figures are not shaded, you're going to subtract those areas from the largest figure. So in this example, you would take the largest figure, which is a rectangle, and then subtract the non-shaded figures, the three circles. So to get a better idea, let's work example A. Okay, so to find the area of the shaded region, first we take note of the largest figure, which is a rectangle. And then we want to take away the semicircle because that's what's not a part of our area. So our first step is to find the area of the rectangle and then subtract that circle, that semicircle away, which it's just half a circle area. So the area of the rectangle is length times width, where the length is 50 and the width is 30. So that gives us a total area of 1,500. That makes up the entire rectangle. But that area does not include the semicircle. So we're going to subtract the semicircle, which is half the area of a circle. So half of pi r squared. And if you notice, the radius is half the diameter, and the diameter here would be 30. So half of that would be 15 for our radius. So we're subtracting 1/2 of pi times our radius squared. So we take 1/2 of pi times our radius squared. And that gives us 353.43. So we're taking 1,500 and subtracting 353.43. So 1,500 minus 353.43 gives us a total area of 1,146.6 feet squared. So the area equals 1,146.6 feet squared. Alright, for example B, you have the area of a rectangle, and this time we're not taking away to find the area of the rest of it, we're adding a semicircle. So we're adding half the area of a circle. Alright, so I'd like you to pause the video and to the nearest tens place, give me the area of the total combined composite figure here. Okay, so you should have gotten a total area of 598.4 feet squared. Alright, in example C, this is an example that we talked about briefly, but we want to take the area of the entire rectangle and subtract from that the area of these three circles. And we're going to assume that all of these radii are 5. And all of these radii are going to help us to find the entire length of the rectangle and the entire height of the rectangle. Alright, I'd like for you to pause the video and see if you get what I get for this next example C. Okay, and I got a total of 64.4 square centimeters. If you have trouble with that, raise your hand or ask a neighbor. And finally, the last one's pretty simple, which is just a formula that we need to follow, and that's the surface area of a sphere. So imagine, if you will, we unraveled this whole sphere and laid it flat. If we figured out the total area that covers, that would give us the surface area of a sphere. And that formula is 4 times pi r squared. Since the sphere is kind of like 3D, we've got to multiply the area of the circle 4 times. So for the first example, it's simply 4 times pi times the radius squared, where the radius in this case is 5. So it's 4 times pi times 5 squared, which is just substituting into the calculator. 4 times pi times 5 squared gives me a total of 314.2 meters squared. Alright, so pause the video and try number 2 on your own. And you should have gotten an area of 153.9 inches squared.